G'day everyone, how are you going? This is our first video on 3D vectors. Now this stuff can get really difficult really quick, but please just think in 2D vector format and add another dimension. That's all we're doing. In 2D vectors we've got our X or our Y component and we've got our J or our Y component. Think in Cartesian form. With 3D vectors we're just bringing in the extra one, the K component, which if you like is the one that's coming in and out of the board. So I could be going this way, J could be going this way, and K is that one in and out of the board. So it's that third dimension. This is how you might write it, and that's absolutely fine. You tend to find that when you get into 3D vectors, writing it as a column vector neatens things up a little bit. For one, you don't have to write I, J and K, because by the position in this column vector, we're told the first one is I, J and then K. So this is a neat little way to write it, but questions will give it to you like this, so you've got to be good with either. Let's talk about magnitude of a 3D vector. Now, for a 2D vector, it's really just a bit of Pythagoras, isn't it? Because you've got an I component and a J component, square both of them, add them together, take the square root, you've got the magnitude of that vector from the origin. We find that with 3D vectors, it ends up being this. Okay, we don't go cubing it, we just keep with the squared idea, and this is why. In 2D, if I had a 2D vector and just the A and the B, so I didn't have this part here, then I'd just do this. That's common, you'd be fine with that. When I'm doing a 3D vector, and notice how I've kept the colour coding the same here. This here is really my 2D vector part of it, which remember that the 2D vector part is flat on the board. So isn't this really the distance from the origin to where that 2D vector on the board would start to lift off the board, okay? Because the A and the B are flat on the board, the C is the part coming off the board. So let's try and get a little diagram snuck in here. If we had that there and the third axis is here, then perhaps this vector in 3D is sitting somewhere out here, okay? But initially what I'm going to do is work that, A and B, and get to that point there. That's what this is. Then this part is really saying we'll square that distance right there and then add the square of C and then take the square root of all of that. Well, by doing that, this part here and this part here cancel out. So we actually just left with A squared plus B squared plus C squared. Think about that in this kind of context, that we're initially working out how do we get to the place where we lift off the board, and then we're squaring that and C to get that distance out to the point out there. Hopefully you can see that. If you can't, play around, you'll get there eventually. Skew lines. Now, in 2D vectors, again, 2D vectors, we have parallel lines or the lines will cross over. They're the only two situations, because you think, parallel lines, no problems. As soon as I kick one of them at a slight angle, they will cross over because in 2 dimension, they all exist on the same plane. But when I get into 3 dimensions, see this square-based pyramid, in 3 dimensions, AB here and DC here are never going to cross over. DC is going to go left and right forever, and AB is that way compared to here, it's further over. So they're never going to cross over. So in 3D we call these skew lines. They're not parallel, but they won't cross over. Now, we can work out the formula here, or the angle rather here. Notice I've put these in brackets because what I've done is I've picked up AB and I've moved it over so that B and C are the same point. So now I do get an angle in here, right? Now it's not actually the angle between DC and AB because that doesn't really exist. But we say they're skew lines and we can work out the angle between by dragging this one across, or I could have taken DC and dragged it across over to there as well. Either would have worked fine. Now you've got a formula for working out the angle of a line in 2 dimensions. You dot them together on one side, you work out the magnitude of the other multiplied by cos of the angle. It works exactly the same way, just that we've got 3 dimensions here. So we need to be able to work out the magnitude of the lines, and we need to be able to dot things together in 3 dimensions. but it works the same. It's just that one times that one, plus that times that, plus that times that. It's a scalar product, remember. That's a great segue into cross product. So, cross product, we're talking about the product with some sort of direction. Whereas dot product is, if you like, the product with no direction. Vector, scalar. Now, what do we got to do? Well, look at this. Here we've got vector A, and here we've got vector B. And I've broken it up into the components, x, y, and z for each. Now, you can see where I've put the red dots. They are the ones where I'm multiplying an x component by an x component. Now, you would already know that's going to give me the dot product, right? It's the same component. It's in the same direction. So that will give me the dot product. All the other ones, the other 6, I'm multiplying, in this case, a y component with an x component. So I'm multiplying different components together. And those are the ones that we put together to make what we call cross product. Now I'll get into why and what and where we can use it in a moment. Let's just follow on through. Cross product, it's a multiply, it's a cross product. And this is the setup that we're going to do. Like I say, that's really just this idea here. Now this is the answer, or the way that we work out cross product. It looks a bit crazy. It's actually not that hard. So what we need to recognise here is that we've got x, y, z components, and we've got to multiply them together so we pick up all of these. Well, the easy way of doing this, and this is going to get a bit messy here, but the easy way of doing this, I want to work out the I component, right? I want to work out the I component. So what I do is I ignore the I component from the vectors that I'm using, okay? And I concentrate everything on the other ones, the other 4. Now you'll notice that it's this one. Oh, that should be a Y. Oh, no. I've made a few mistakes here. I'm going to make a little bit of a change here, sorry. I've gone X, Y, and Z here, but I've used I, J, K down here. Okay, I'm just going to make a change here and change these to I, J, K. I just noticed that I've kind of labelled them differently. It doesn't really matter. There we go. Okay, that's better. Now, you can label them X, Y, Z or I, J, K. It doesn't really matter. You've just got to follow through with the same notion here. That's neat now. So, back to where I was. I'm working out the I component, so ignore the I component from your original. Then I want to take that one times by that one minus that one times by that one. And the answer to that will be the I component of my cross product. Now, in a similar way, I'm going to bypass the J for a moment. I'll come back to that. I'm going to go to the K, right? This is the K component that I'm working out. I said this is going to get messy. I apologise. Ignore the K component. Look at the other 2 components. Notice AI, B, J, it would be this one multiplied by that one minus that one multiplied by that one. And that would get me my K component. Now the J component, it's a little bit trickier, Now, I want to come over here and have a look here first. If I go A cross product B, you would agree that the A vector I can write like this, it's got an I, a J, a K. The B I can write like this, I, J, K. Now get rid of the A's and the B's for a moment, right? Just look at the order of the components. Just look at the order of the components, right? Notice when I did I times J, right? That was the order that I write them in. The green, well that was neat because that was the order that they were in, I and then J. When I do the J and the K, that was this part here, it's in order, right? J and then K. But when I do the KI, it's kind of in the wrong order because here it's IK, right? So what I need to recognise is that it's kind of not in the order that I want, but being a vector, can't I just put negative IK? Because if this is a vector that I'm going to create out of this, then KI is equal to negative IK. And now IK, it's in the right order that I've got here, I then K. So what I do is this negative effectively comes here, and it means that then I can follow the same pattern that I did with the other 2, I don't have to change this up. Okay? So it's just a little trick to make it a lot easier. Now, I'll try and not make this super messy. Doing the J component. Get rid of the J's. We don't want them. Right? We're not using the J component to work that out. We're going to do this one times that one. Notice IK. It's in the right format, isn't it, with this negative? It's in the right format. IK multiplied, minus this one, which would be AKBI, AKBI. So we can follow the same pattern if we just recognise that actually that middle one was the wrong way around, put a negative in there, and it makes it work for us neatly. Now, here's the thing, and I haven't got enough space on the board, but what I want you to do, I want you to write a vector A and vector B along an axis. Okay? So I'll give you them. Here we go. Write vector A as 1, 1, 0, 0. Now what would that be? Well, that's going 1 along the x-axis, or the I direction, and nothing on the j and the k. So that's going to be on the x-axis somewhere here. Okay? Then use vector B and go 0, 1, 0. What's that doing? Well, that's along the y-axis, isn't it? So that's going to be somewhere up here, right? 1 unit up there. Now, if I cross-product these two together, I'll give you the answer here. If I cross-product the answer, you should get 0, 0, 1. Now, 0, 0, 1 is going to be from here, 1 unit out this way. Now, what is that telling me? Well, this vector here, which was vector A, right, and this vector here, which was vector B, right, those two vectors define the plane that is this flat board. Okay? They both sit on the plane of this board. And what A cross product B gives you is the normal to that plane. The normal to that plane. So the normal to that plane is going to be this one coming straight out here. Now, before we get past this, we've got to talk about the right-hand rule. Now, if you've done physics, you've already done the right-hand rule in a way. But in this sort of thing, how does it work? Well, the first vector, use this finger, right? Point to it. The second one, make this finger as close as you can, point to it. And then wherever your thumb points is the direction of the normal. So this is A, this is B, and that coming up off that plane is going to be the direction of the normal. Now think about it. If I rearrange A and B, swap them over, then it would be A, B, and notice how the normal now points the other way. So if I swap these two over, the normal points the other way. So that would tell you that the order of these is actually important. In a dot product, it doesn't matter because you're getting a scalar product. But because this is a vector product, if you go A and then B, your normal's up here. If you do the opposite, A and then B, your normal is the other direction. Now numerically it's going to be the same, right? Numerically the same, but the direction is going to be different, all right? So let's just check this out. If A, and I think I might have this around, no, I've got this the right way. If A is that way and B is up that way, as best as I can, then then the cross product is the one coming out of the board, isn't it? But if I did B cross product A, it would be B, A, and the one would be into the board. There's a lot in this. If you've kept going this far, you're doing very well. There's a lot in this, there's a lot of thinking. Do a couple of simple examples, get your numbers working, and always try and think, what am I actually figuring out? What am I interpreting here? Well, cross product gives you the normal to the plane that contains vector A and vector B. Hopefully this one's helped. It's a lot of thinking in here. Please rewatch. Let me know if you want me to do some questions. More than happy to. Catch you later.